Okay, let's try this here. Number 29 and number 56 from page 795. All right, number 29. Here was our given. We're given this trapezoid. We have this leg of this trapezoid, which is the hypotenuse of this right triangle right here, to be 2, and we have this altitude to be 3. Now, the angle we're supposed to find is this great big angle that is not part of this small triangle over here on the left. But notice that it is simply this little angle, which I have marked with a green dot, plus 90 would be this big angle theta right here. So then let's just simply look at this small triangle on the left. Let's just cut that off, and then here's what it would look like right here. Okay, there's theta. Now from theta, or I called it theta, probably shouldn't have. It's that little green dot right there. Okay, adjacent to it is a square root of 3, and on the hypotenuse is a 2. So that's a cosine. So we can say the cosine of this angle is square root of 3 over 2. Grab our calculator, do an inverse cosine of square root of 3 over 2. The calculator gives us 30-degree answer. But we got to remember what that was. That's not our overall answer. That's just that little piece right there. Well, how big is this full angle then? Well, it's the answer we just got, 30 plus that other 90. That's how we get to 120. Now, number 56, you have to remember a little bit of geometry. This talks about a drawbridge. I think that's what it was. But here's our setup. It's another, what do you call it? Trapezoid. Okay, and it's actually an isosceles trapezoid. That's going to come into play here in a second because those two legs are the same. Now you have to think here a little bit. Remember, this is a drawbridge. So these are going to swing down and let people drive across it. And so that means when those both swing down, if they're both 120, then this total length down here is 240. Now let's take a closer look at that. So the bottom of that is total of 240. All right. But the distance between these two drawbridges when they're open up here is 100. Now if I take that 100 and I drop it down to the bottom, then it's going to be sitting right in here in the middle of the bottom of this road. Now the overall length is 240. If I take that 100 out of there, that leaves me 140 left over. Well, how do you think that's split up between these two other small pieces? It would have to be evenly. So this would be a 70 and that would be a 70. Okay? So what that means, if you can still decipher my drawing, if I drop an altitude down right there, so I make a right angle, and I create this triangle right here. Let me create some room. Now we'll bring it over here and let's draw it. That little triangle there on the left, that has a theta in it that we're trying to find. That's 120, and we know this is 70. Now on the other side we could do the same thing, but it would be the exact same triangle. It would have a 70 adjacent to my theta and a 120 on the hypotenuse. So we get two exact triangles on the outsides of that trapezoid. Now if it's adjacent and hypotenuse, then that is a cosine. So we would say the cosine of theta equals 70 over 120. So theta is equal to inverse cosine of 70 over 120. Okay, which means, or our calculator then gives us a 54-degree angle for an answer. Hope this helps.